Sorry, we're still.
Sorry, it's a really serious photo of me.
Yeah.
I got told I need to remove it, but I think I look quite professional, so I've kept it. Awesome. Okay. Thanks everyone for coming along this evening. It's pretty exciting having, all the girls up here having a chat to you all. So my name's Anna. For those who haven't met me before, I work for a company called Allura Infrastructure as an advisor. And today I'm going to be talking not so much specifically around BIM and digital engineering, but a little bit more around digital twins and broadly how they can help improve outcomes when it comes to infrastructure. So I think most of us sitting in this audience have probably seen a kind of digital solution or digital engineering project that's been developed, but for whatever reason, they haven't managed to actually get the real benefit out of the digital solution. And it could be something like, the underlying data is really poor quality, so people don't really trust it. It could be that senior leadership aren't bought into what the solution is doing or doesn't understand it. There could be a lot of different reasons why digital solutions don't actually deliver the benefits. So today what I'm talking about is why planning properly at the beginning and thinking about what those final outcomes look like help us get better value out of our digital solutions. So I'm going to be talking around a specific example out of the UK water sector today. So for those of you who are not familiar with the UK water sector, they're facing a really big challenge around the future security of water supply. Similar to New Zealand, they've got projected climate change changes, projected population growth, which means they've forecast that by 2100 they need an extra 55 billion litres of water per day. And to put that into context for New Zealand, I think that's about 35 times our current water supply that we use as a country. So they need 35 times more water than we have right now. For those of you who are not familiar with how the UK water sector is set up, there's 11 different water companies, and there's a lot of variation between those regions. So in the north, they're really wet, they have a lot of water. In the south, they have drought, so there's a lot of variation between those. So to be able to address this kind of future water scarcity issue, they identified 27 or 28 different schemes that were going to help solve this. So they were things like building big reservoirs, building big water transfers that take water from the north to the south, desalination plants, lots of different schemes that are going to help solve this problem for the whole country. And the regulator, when it set this out, kind of recognised that this wasn't going to work if the water companies worked by themselves or treated them all as individual projects. They really need to work together and think about the water sector as a system to be able to actually deliver these outcomes and get safe, secure water supply. And so because they kind of recognised this need for it to be viewed as a system, one of the things they asked all the water companies produce was a digital twin and a digital model during design to help think about the systems view of these different solutions. And I think I'm probably preaching to the choir here, but I thought I'd just chuck this in just for anyone who doesn't understand what I'm talking about. So I guess digital twin's not going to get into a real detailed definition around it, but it's essentially having a digital representation of a physical model. And that might be at the beginning a digital model, right, which is what we develop during design of a new building. And there's kind of manual data going from the physical to the digital asset. You might have a digital shadow. So there's kind of one-way near real-time data going from the physical to the digital asset. So for example, if you had live information on like diggers and earthworks during construction coming into a model, that could be a digital shadow. And then the digital twin, which is, two-way real-time control, things like, ammonia control at a treatment works. You get information about the temperature and it changes something in the treatment process. So for the simplicity today, when I talk about a digital twin, I could be referring to a digital model, shadow, or twin, but I thought it'd be worth just kind of calling out that there is a difference between all of them, but I'm keeping it simple. So, we'll keep them all as one for now. The other kind of concept that I wanted to touch on before I dive into this case study is that infrastructure is a system of systems and it exists to be able to improve outcomes for people and places. Infrastructure isn't an individual asset. It's not about delivering individual projects, right? You need to think about it as a system, and that's how we actually get more out of our infrastructure. And I think the National Infrastructure Commission put a big report out earlier this year, which got a lot of hype. But one of the key things they put out, which is pretty sensible, was we need to do more with the assets that we have. Instead of building big new shiny projects, we need to understand our assets and make sure that we're getting the most out of them. I think this concept of systems thinking is a key way that we can get more out of the assets that we have and think about how we use them more constructively. And by thinking about infrastructure as a system, we can get better outcomes out of them. And of course, digital twins is key to being able to unlock this kind of systems thinking. Digital twins of infrastructure allow us to be able to connect different digital assets together. They allow us to better understand how one might impact another, and they allow us to test out interventions virtually. So that can help us inform kind of design decisions and how we're going to operate our assets. So this is the program that I was working on when I was in the UK. So to give a little bit of context, I was the digital lead on the program for a couple of years. So initially helping set up all the CDE systems, information management processes, things that we think of when we think of digital engineering. But towards the end, one of the things we developed was a digital twin strategy for the program. The assets themselves that was being developed were 2 reservoirs, 2 water treatment works, and 2 major transfer pipelines. And you can get an idea of the scale by looking at this slide. So there's a little town off to the side, right? It's basically building a huge man-made lake. And because of the scale of this, there were some really important decisions that needed to be made to make sure that you could provide that secure water supply while not having any negative impacts on the existing environment and society. So being able to understand when they're looking at where they're taking the water, there's an upstream river that they're going to be taking this water on to feed this reservoir, thinking about how much water they're going to be taking. There's lots of different aspects that impact that decision. So if we think about, there's farmers that rely on that water for their farming activities, there's archaeology findings, there's like aquatic life, all these things have to be thought about when you're deciding how much water you could take out of that river. There's also different factors that impact how much water is available, things like temperature, precipitation, tides, water quality, all of these different factors that come into basically saying how big are we going to make this reservoir and how much water can we take out of the river. And so the water companies looked at this and thought, crap, this seems pretty complicated. And they're like, yes, we also recognize that we need a digital twin or digital solution to be able to actually understand all these different factors and how they're going to influence it. So I guess we had the need from the water company that we need a digital twin. We had the regulator telling us that we need to do one as well to be compliant with the delivery process. But then the question is, this asset isn't going to exist for 15 years. Digital technology changes every day. So what could we actually do as an organization that actually built up some capability and moved us forward without locking us into technology that's going to be obsolete in 6 months, or developing a pilot that's just going to sit on the shelf and just waste money? And that was kind of the challenge that we had to wrestle with when we're looking at this. And so we kind of made a deliberate decision at that stage that we weren't going to dive into defining a solution or developing out really detailed requirements, but instead trying to think about what we need to do to create the right environment and set the right kind of foundations to be able to develop this digital twin, and also trying to really understand what the end look like and what outcomes we're trying to achieve as a system. So I'm going to take you through now a few different things that we did to develop the strategy, to try and give you an idea of kind of the thought process that we went through to try and build out essentially the strategy and the roadmap for how we're going to get there. So the first one was just trying to make sure everyone actually understands what you're talking about. So I guess you guys, if you're at the BIMinNZ event, you're pretty familiar with maybe talking to senior stakeholders in your organization or at a client who they don't really know what you do, they don't really understand, they don't really care, to be honest. And one of the first things we did was just trying to make sure everyone understood what the digital twin strategy was and why we were doing it. And that wasn't around, coming up with a really detailed definition. It was more around getting everyone into a room, using some real world examples to be able to explain what we're talking about, and getting people to tell us what they thought the value was out of it. And that just meant that everyone was starting with the same context, everyone understood what we were doing, and it meant going forward, people actually bought in to this piece of work that we were doing. So the second piece was around defining a vision, which, for those of you who work in strategy, vision is kind of the key first, most important thing. And you guys might look at this and say, these look quite similar. You might also look and say, I could probably just get Claude to produce one of these for me in about 2 minutes. So why do we need to go do a workshop for it? And I'll let you in a secret. One of these actually was just generated out of ChatGPT. And the other one was generated through getting all the senior leadership together, getting them to talk about what the value was of digital, what they wanted out of it, and how it was going to help drive the program forward. And there were kind of 2 different things that came out of that approach, right? So the first one, the digital twin vision, which was actually generated with people, it meant that senior leadership again were bought in to what we're trying to do because it had the opportunity to contribute towards the vision. They were aligned and we all knew what we were trying to end for. This one, it looked good on a slide and then it just sat in SharePoint, and yeah, that's about it really. So I guess the point being is having that conversation, although it's like a slightly softer thing to do and sometimes feels a bit less exciting for people who are more technical, it is really important to get those kind of senior people to board into what we're trying to achieve. And then the last part around setting up the foundations was looking at the capability and maturity. So this was probably the kind of meat of the strategy, I would say. So instead of diving into looking at a solution, we thought about what are the key capabilities that the organization needs to be able to get to that final piece. And I think coming back to my earlier point, probably all seen those digital solutions that, the visualization's awesome, but, as I said, the underlying data just is crap. People don't trust the solution, or it's got really sophisticated analytics, but the operators don't know how to use it or they can't access it. And so that just doesn't get adopted and it dies. I think if you don't have at least the base level across all these capabilities, a digital twin solution can come unstuck really quickly. And so when we were developing out, we were thinking about what we needed across all of those pieces to make sure that we could actually start building together. It also helps kind of avoid the other issue, which happens often. You'll have a project delivery team, they'll do something really innovative and really awesome. And then when they hand over at the end of the project, the client isn't in a position to be able to take that solution, scale it across the organization, actually get the full value of it. So the value of that solution dies with that project team. And so by actually having that capability as a client organization, I know I'm saying the word capability a lot, but hopefully this is making sense. Having that capability means that when those cool digital twin or digital solutions are developed, the water company can actually take that and own it and take it going forward instead of it kind of ending with the end of that project. In terms of how we applied the maturity model, so we kind of looked at targets from 1 to 5, so 1 being kind of traditional reactive silos, 5 being higher levels of connectivity, more kind of predicted optimized decision making. And we kind of had a top-down view of what we thought we needed, but also actually looking at specific use cases or things we know that were important in each of the stages. So for example, we knew during design, this scheme is really, like stakeholder engagement was really important, probably more important than design for this one at the early stages because of the disruption and the size of the thing. So we really focused on making sure we had the right visualization and then the ability to kind of share the different designs with different stakeholders. We knew in construction that because it's such a large amount of earthworks is going to have a really big impact on capital cost and capital carbon. And so we wanted to make sure that by that stage we have good data availability and be able to actually track that in near real time. And that kind of helped us think about what levels we want to get to at each stage in the program. So I think that's kind of what we did to set the foundations. The other part we did is think about what we're trying to achieve at the end. So thinking about that broader system and those system outcomes. So this map is actually for a nearby river, not the reservoirs, but we went through a kind of similar process. It's trying to think about what's the natural environment, what are the factors that are influencing that, what are the existing constraints and existing assets, and then what does the new assets look like as well. So mapping out all those different factors to try and get a system-wide view of what was happening. And a nice example that came out of this for the reservoirs was typically they'd look at kind of the hydrology model and the water quality model as 2 individual models, and you'd be looking at those separately. When we went through and mapped out this whole piece, they kind of identified that was a really big risk because there was an assumption that water quality wasn't going to impact the volume of water they could abstract. And they said, actually, that's too big of a risk for the program because it really impacts so much of the design. And so they developed a new model that took together hydrology and water quality so they could actually understand the interaction between those different parameters, and that helped them make more informed design decisions. I feel like I was going to say something else more about the slide, but it's gone, so hopefully it wasn't important. And the last piece is around understanding the end user. So I know I've been guilty before of designing a digital solution that was pretty good, but actually wasn't really solving the right problem. So I think there's something to be said for just making sure you really know who the end user is. You've actually talked to them and you've got that problem statement really well defined. And it's not about going through and developing again, pages and pages of user requirements. It's just around engaging with them, making sure you're understanding what they want, and also getting them bought in. So a lot of these operators or people who are kind of inheriting the final asset, they want to know that digital is going to help them. It's not going to replace them or make their jobs harder. And so there is a big piece around the change piece. So one of the other schemes that this water company was doing, they ended up investing, I think it was about £5 million just purely in change and training for the operators. So something that should not be underestimated, and it needs to be kind of included in your budgets when you're thinking about how you're going to roll out different digital solutions. So I touched on quite a few different concepts there. I was just going to reiterate a couple of key points just to leave you with. So the first one is starting with the people, not the solution. So making sure that if you're looking at a kind of digital strategy, you've got buy-in from senior leadership, they understand what you're trying to do, and you've got that right level of sponsorship. Also making sure you understand who the end users are and what they're trying to achieve, and that they're also bought into what you're doing. The second one is focusing on that foundational capability instead of the solution. So by starting with that and building it up that way, you can kind of move yourself forward in a way that you're not going to end up locked into a technology that becomes obsolete, or developing something that's no longer useful in kind of a couple of years' time. And then the last piece is being able to think about something as a system. So instead of looking at a project, zooming out to a program or the existing natural built environment, which is not necessarily easy to do, but it can help you identify kind of cheaper, greener, better solutions when you start thinking about things on a broader scale. And that's me. Any part-time? Thanks.